A bicycle is traveling 6 meters per second. If the tires have a diameter of 66 centimeters, find how fast the wheel is turning in rotations per minute. So thinking about what's going on here, here's our wheel. The diameter, so the distance straight across here, is 66 centimeters. The wheel is moving forward at a linear speed here of 6 meters per second. My goal is to try to figure out how fast that wheel is turning in rotations per minute. Essentially what we're doing is we're switching from the linear velocity of 6 meters per second to the angular velocity in rotations per minute. And while we can play around with formulas, it becomes a lot to memorize and a lot to play around with, we can deal with this problem just by thinking of it as a unit conversion and do some dimensional analysis to do the changeover. I'm starting out with 6 meters per second as my linear velocity. Again, I'm trying to change into rotations per minute. So I need to change the meters into rotations somehow and the seconds into minutes. Seconds into minutes is probably the easiest one. Notice that seconds is in the denominator. So if I put seconds on the top and minutes on the bottom, remember, of course, that 1 minute has 60 seconds, so I have an equivalency fraction there. The seconds will cancel out, and now I am left with meters per minute. All right, a little bit closer, I have meters per minute, but I still need rotations per minute. So somehow I'm going to have to change from the meters into the rotations. All right, now in order to think, basically what we want to do here is we need to figure out how, what the distance is going around that circle, because that will be the number of rotation, or the distance around the circle will be equal to a single rotation. The distance around the circle is called the circumference, and we have a formula that will allow us to do that. And the formula for the circumference is c equals 2 times pi times r. Now, all right, so that sounds great. The circumference in this particular problem, notice, is going to be 2 times pi. My radius is given to me as my diameter is 66 centimeters. So my radius is half of that distance, which is 33. So I can think that my circumference is going to be 66 pi units, but my circumference here is in centimeters because the diameter or the radius measurement that I have here is centimeters. Well, that's going to cause me a little bit of problem because the unit that I have right now is meters. So let's take a second and change our meters into centimeters so that we can deal with a centimeter conversion. So here my meters are going to cancel. Remember that there are 100 centimeters in 1 meter. So there's my next unit conversion equivalency. And now I can say that the circumference, which is 66 pi centimeters, is equal to 1 rotation. And now I am able to get my centimeters units to cancel, and I'm left with rotations per minute, which is exactly what I want. So now I just need to get the numbers to resolve now that my units all work out. So I'm going to have an answer in rotations per minute. I'm going to multiply all the values across the top, which is going to give me 36,000. And then I'm going to multiply all the values across the bottom. So 1 times 66 pi, which is approximately equivalent to 207.35. And that's kind of a weird number, so we'll just go ahead and divide those, and we'll end up with about 173.6 rotations per minute as my solution.